Hello, welcome back to physics, my fun-loving physics students. All right, so this time we're going to be looking at forces in two dimensions. So we looked at force in one dimension, sort of just, if one force goes against another force, and we look at the idea of vectors. So we learned that if we have a vector going this direction, and say that that vector has a value of 5, sorry, this is supposed to be a straight line. So that vector has a value of 5. And let's say that we have another vector that is going in this direction, and that vector has a value of 3. We can add these vectors. And so to add vectors, what you do is you take the two vectors and you place them tip to tail. So here's a tail and here's a tip. So if I was to place this tip to tail, I would take this vector and place it like that, tip to tail. And so it's gonna work backwards on that, and there's going to be 3 of them, which is going to leave me a resultant vector. Put that in a different line. A resultant vector, which is going right here, and that resultant vector, of course, has a value of 2 in the right direction. And so very, very important that we always do that, because force is a vector quantity. So force equals a vector quantity. So one thing that you always need to make sure to do is add direction whenever you define a force. So force has to include direction because it is a vector. Remember, scalars just have magnitude. But what if we're talking about force in 2 dimensions? And so what if we, every time like you kick a ball, right? So here's a ball, maybe you kick it. You kick the ball maybe at an angle like this, right? And so when we look at that angle, it's actually, you have 2 force vectors here, okay? You have a force vector that's going in the horizontal direction, and you have a force vector that's going in the vertical direction. So 2 dimensions. And so this right here, what we call the resultant, is going to be actually you could use trig functions, but it's a part of a triangle that results from, this, we call this ry, and this one rx, right? So that we have a y direction and an x direction, and this is our resultant vector. So, but you can add vectors by simply placing them tip to tail. So, so let's say that we said that we had 2 vectors. We had one vertical vector and one vector to the right, right? And so how would we add those? Let's say that both of these are 5, right? So we have 5 up and then 5 to the right. So what is the resultant vector of these 2 vectors? Well, what we're going to do is we're going to take and we're going to put those tip to tail. So let's go ahead and do that now. So I'm going to take this one right here. I'm going to move it over here so I have this one now tip to tail. There we go. And so then what we're going to do is we're going to draw the resultant. Let's get a different color in here. Let's go with a green. We're going to draw a resultant. And the resultant vector is always going to be drawn from the tail of one. That's kind of here it is, the tail of one to the tip of the other one. So here's a resultant vector right here, and you can see that this makes a triangle, and since this was straight up and this was directly to the right, this is going to be a 90-degree angle right here, right? And so and we know that this one was 5, this measurement over here. So how would we figure out the resultant vector? Well, in order to do something like this, you would just use Pythagorean Theorem, because we have a right angle triangle. So r squared equals a squared plus b squared, right? And so this is pretty simple. So r squared equals 5 squared plus 5 squared. So r squared equals 50, right? And so then we would take the square root of 50 to find our resultant, right? And so the square root of 50 is 7.07. So this value is 7.07. Now, it's not just 7.07. So what would we say? We have the right direction and the vertical direction. So we would actually have to use a vector quantity. We have to use a direction in here. So it would be 7.07 in the right of vertical direction. So right of vertical direction. Yeah, and so it's really, really important that you in some way or another define the direction. I mean, even if it's simple as that, right? And if you were talking about north and east, you could say this is east of north in a direction right here, or it would actually be north of east, whatever, if you knew what this angle was right here. And you could solve for that angle using trig functions. Let me also point out that if you end up with a resultant vector that you're trying to solve for where your angle is not 90 degrees, you're not working with a right triangle, then you need to use the law of cosines. So this is Pythagorean Theorem, and this will work for any sort of a situation that you have a 90-degree angle. If you do not have a 90-degree angle, you would want to use the law of cosines. So law of cosines. And this should be familiar to you from math class or whatever, but if it's not, still pretty simple. So law of cosines says that the resultant squared, or r squared, which is the hypotenuse of the triangle. In our case, we call these resultants, okay, equals a squared. So a is going to be one of the sides plus the other side squared minus 2 times that side, a side times b side, times the cosine of the angle between them. So the angle between a and b, and you take the cosine of that. So this is the law of cosines, and this is for angles other than 90 degrees. All right. So that's just kind of a quick little introduction into looking at physics problems in 2 dimensions. So oftentimes we have to be breaking stuff into triangles, and there's a lot of different things we can do with that. And so some of the things that you're going to need to remember as we go through this is law of cosines, Pythagorean theorem, and also this whole idea of tip to tail. So as you're putting vectors together as tip to tail. Okay. So what we're going to do in the next video is we'll go ahead and solve a problem that's a little bit more complex than this problem that we did right here, and it should be helpful for you to sort of understand how we use this. All right. Thanks for watching. Tune in to the next problem solving.